So, briefly, before I forget, as many of you know, a bunch of lunatics will descend upon the campus next Thursday. Richard Spencer and his Mary Band of Idiots. The classes have not been canceled. However, if you are concerned at all, you are not required to come to this class. I'm saying you may stay home if you want. I am going to try and record the lecture next Thursday so that you can watch it remotely. So if you have any concern, I don't want you to feel nervous. I don't want you to feel insecure on campus. So when the white nationalists are here, you are welcome to stay home and watch the lecture remotely later if you want to. Okay, so just be aware of that. I don't demand that you come here in that case. Okay, so I can wait quite a while. That's not working, is it?
No. Just start talking.
You guys gotta be quiet. Shh. Shush. Shush. Okay. So, a bunch of people asking, and I did mention it last time, but just in case you didn't hear what I said, you didn't see the many alerts that I obnoxiously put in Slack, Project 2 is still on track to be due on the 20th. It is, you are required to use arrays. You may not use the Java sorting function. Those are the big limitations. So please keep that in mind. Today what we're going to do is I'm going to briefly, I know somebody already said, I've already seen this slide like 3 times. I know. I'm not going to read it again. I promise. I will not read it again. Also, we are trying to get through the exams. There are 600 people in this class, and we're trying to get through them. I was upgrading until 11:30 last night, and I came back in at 8:30 this morning. So we're trying to get there. But, it's going to take some time to get through everybody. We really can't release part of the grades. That's really unfair to the people who we don't release the grades for. So we're going to get through all of them. We're going to make sure they're right, or at least as right as we can get them, and then we will release them. As soon as we finish with the exam grades, we will get to the projects. And we will go through them. And I actually think the projects will go faster because there's less subjectivity. Like, we have to be careful when we're grading essay questions because we need to be fair. Being fair with essay questions it's hard because everybody's a different person. So just be aware of those things. We are working on it, and we will keep working on it. I've had to say this a couple of times, and I'm just going to say it to everybody just to make sure everybody knows. It is not practical for me to answer code questions up here during lecture about your personal project, okay? So I'm not saying that because I'm trying to be mean. I am mean, but that's not why. It's impractical. The lines would be super long. You really need to go to office hours. So I have some people who've set up office hours to come see me. You can also go to the TA office hours. All right. Does anybody have any questions before we get started? Yes.
Do we also send email questions?
Can you send email? You can send email, but office hours are better because emails we get to when we have time. If you make an appointment for office hours, or you go to office hours, that time is dedicated to you. That is what that time is for. So if somebody sends an email, then if nobody comes to office hours, we respond to the email during office hours. But if somebody else shows up, then your email falls to the back of the queue. Okay. Yes, go ahead. Are you allowed to what? Import arrays? You mean like the Java array class, like the utility class? Yeah, absolutely. Go for it. Go to town. Yeah. You can use any of the functionality. What you have to use is the basic data structure type of an array. That's like the mandatory requirement. Okay, so last time we talked about iterating through containers like arrays, and we looked at some loops and ways to do that. I want to show you one other way that Java and a lot of other languages have built in to go through container-type objects, and that's what we call iterators. An iterator is a special object that keeps track of where you are in some container. And you can basically ask the iterator to go to the next item at any time. It'll skip forward. It'll always keep track so that you don't have to. So in our previous example, we had this. I'm sorry, I know that the potato example is probably getting old by now, but it's what I have. So if you have a better idea, let me know. So we have this array of strings called potato, and then what we're going to do is we're going to create an iterator out of it. So there's a couple of steps here. There's a class in Java called stream that makes it easier to package things up into iterators. You don't have to worry too much about the details, but this right here is how you can create an iterator from an array. So you do arrays.stream, that prepares the data, and then you do .iterator, and that'll create an iterator for that type. And the way you define an iterator, the type of an iterator is you do iterator, and then in the greater than, less than symbols, you put the type. Pretty straightforward so far? This doesn't work quite the same with primitives. This is mostly for reference types, but you can do it with primitives in a good way. So once we have that, then what we can do with this iterator object, remember, it's going to keep track of where you are on the list. We can ask it, are there any other items left that I haven't seen yet? You ask it has next. If has next is true, that means there are more elements left to go. If it's false, that means we've run out of stuff to look at. Make sense so far? Okay, this is a really common construct. It exists in almost all object-oriented languages. It does not exist in the C language, but it does exist in C++, and Java, and C#, and I'm pretty sure it exists in Python and several other languages. When you want to grab the next element, it's pretty simple. You say to the iterator, hey, give me the next one. Give me the next element in the list. And what it'll do is it'll go through, it will loop over and over again, ask if it has another element. If it does, we're going to pull that next element out. And then we'll say, do you have another element? And if it does, we're going to pull that element out. We're going to keep going until we get through the whole list. Yes?
So the iterator is just basically holding like the value of your array, and then it's just going to say, okay, is it going to keep going, get to the last one?
Yes, I'm going to rephrase what you said, but that's correct. Yes, basically what it does is it keeps track of the data structure you're working in and where you are in that data structure. And so every time you ask for a new element, it's going to move on to the next one and give you the next one.
So it basically knows everything in the heap.
Well, it doesn't know everything in the heap. It knows everything about the data structure that you set it up to go over. So in this case, we set it to go over this particular array, potato, right? So whatever you set it up to go through, that's what it's going to go through. Does that make sense?
In a way, yeah.
In a way? Okay. Chew on it. If you still have a question, let me know. Yes? Can you tell it to stop before the last index? Was that your question? Yes, you can. There's a bunch of additional functions in iterators, and in fact, you can, this is just the default, right? You can actually make an iterator and say, I only want this iterator to go from here to here. You can actually give it a range, and you can tell it, I only want it between these two areas, and it'll only go over those areas, and then it'll stop. So there's a lot of flexibility. Does that make sense? Okay. Yes? What's the difference between an array list and an iterator? So an array list, that's a good question. We're actually going to talk about array lists a little bit today. The biggest difference is that an array list is a data structure that wraps around an array. But the iterator keeps track of where in the array you are. Like, that's the key. So an iterator has like, I am here. Like, an array list doesn't have that. It's just pulled to the same elements. Does that make sense? It's like you have an arrow saying, this is where I am in the list. It's like the difference between a list and like a pointer to somewhere in the list. Like if you have a bunch of stuff and you have somebody pointing to one of the things, the person pointing to one of those things, that's the iterator. The big list of stuff, that's like the array list. Okay? Right. But if you're confused by the array list talk, that's the question is relevant because we're going to talk about it in a minute, but we haven't covered it yet, so it's not your fault if you're lost. Okay, anyone else? All right, so we talked a little bit about multidimensional arrays, but I want to go back to this example very briefly because I want to talk about what happens in memory. We started talking last time about the heap and how the heap is different from the stack. And it's important for us to understand what's actually happening in the machine, in memory, so that we can avoid some types of problems. So we have the heap, right? If you remember that the heap is where we store all of the objects that references point to in Java. In this case, we have this enumeration x0, which was for tic-tac-toe, and actually the objects x and 0, they're actually stored on the heap. So we didn't talk about this before, but whenever you create an enumeration, it creates a bunch of values, and those values go on the heap. Then when we start up our main method, we introduce a stack frame, right? So this is the stack frame for main. It's got arguments. So far, this should be pretty straightforward. When we create a multi-dimensional array, what we're doing is we're creating a reference, a pointer, and in this case, it's going to point to an array. It's pointing to an array of arrays. So when we bring this next element in, this is an array all by itself. It's an array inside of another array. So we have board, and that points to the first array, and then it has 3 different entries, one for each row, and each of those rows is going to be another array, and that's going to hold the values. Any questions so far before we move on? Yes, go ahead.
So since like the tic-tac-toe board has, it's like a multi-dimensional array, so it has an array inside of an array which like specifies certain points as well.
That's correct, yes. So it is basically an array that is inside of an array. Well, it's got several arrays inside of one array. It's an array of arrays. Okay?
All right. Okay, and so that, and since the argument is already defined in the main as a parameter up there, and the main string is an array. So.
Oh yeah, I actually should have put that in the heap. I didn't. I should have put what ours points to in the.
I was just trying to think where it was going with that.
Yeah. I just have it there because it's part of the stack, but also actually I should have an object down here. Honestly I didn't think of it. So thank you for thinking of it. Yes.
What line creates the 3
What
boxes?
line creates these 3?
Yeah.
That's this line here. Let me go back. That's this line right here creates these 3 elements.
And which line made the ones that go like this?
These came from basically this bracket here because you can't see it yet, but eventually we're going to have 3 lines, and so it goes and has.
Oh, okay.
Okay. Yes, go ahead.
The 2 sets of brackets after tic-tac-toe make it 2 arrays?
This bracket, these 2 brackets here, you mean? Yeah. So these square brackets, that's what makes it a 2-dimensional array. It makes it an array of arrays. Does that answer your question? And if I wanted a 3-dimensional array, I would have 3 of those sets of brackets. Cool? Anyone else? Yes.
Is there a limit on dimensions?
Oh, that's a great question. Is there a limit on dimensions? I don't think so there's always a technical limit. But practically speaking, no. Like, you can have as many as you want. You're going to run out of memory at some point, and I'm sure there's a limit to the number of indices in Java, but it's probably really high. It's probably like 32,000 something, or 65,000, something along those lines. So could you have 65,000 dimensions? Probably, technically. I don't think it's the greatest idea in the world, but you could do it. But if you have 187 dimensions, I think that's fine.
Is that a Rick and Morty joke?
Yes, it's a Rick and Morty joke. Sorry. Yes, that was a Rick and Morty joke. Yes, go ahead. Okay, the question is, this top horizontal row here, where is that represented in the code? This one's tricky, but basically it's these brackets here. Those, because we're eventually going to have 3 rows and it needs an entry for each row. But these initial set of brackets, they define the first level of the array. Well, what is indicating? Well, if we go through the rest of it, right? The fact that there are 3 lines, that's what indicates that there are 3. Yeah, what's that? They're set up prematurely on the slides. Yes, that's right. Okay, anyone else? Okay, so as we add lines, as we go ahead and we instantiate these inner arrays, the next one is null tic-tac-toe.o.null. So remember, we have these enumeration symbols here, and what's actually going to happen is we're going to point to that enumeration symbol, right? So this is actually a reference type, which was a question I got earlier from one. Enumerations are reference types. That means that they basically point to stuff in memory. They don't hold the values themselves. All right, and just remember that null is what we talked about before. That means you point at nothing. You're not pointing at anything if you're pointing at null. Technically, the values of null is 0 in most computers. Okay, any questions so far? I think we're going okay so far. All right, the last line is null, null, x. So when we add that line, then this last entry is going to point to x. So that's how it occurs in memory. This is another way you could set this up if you wanted to. You could also set it up from the start as a 3x3 array, and you could assign specific values to the non-null elements, and the rest of them will be null.
Is that the same? Is it
These two sections of code would have the same effect.
like
Yes.
yeah, same effect, but
In memory.
data box. Oh, okay.
Yeah, the data would be the same as well. Yeah. Okay. Yes. Go ahead.
For like the board, why is like board 2-2 and like third column?
The question is, why is board 2-2 the third row and third column? And the answer is because this index is 0, 0, so it's 0, row 0, column 0. This is row 2, column 2. So remember, we start counting from 0. What's that?
But you don't do that with like.
Right, but you don't do it with the size. With the size, you're actually showing the actual size. It's just when you're counting what number you're at. Cool? Okay. Anyone else? Okay, so we actually saw this last time, but I wanted to cover the heap stuff. Another type of array, oh yeah, and then after the program ends, the stack and the heap, they come off. So, there's another type of multi-dimensional array we haven't talked about yet, and that's what we call staggered arrays. And staggered arrays mean that we have an array of arrays, but the inner ones can be different sizes. They don't all have to be the same size. In the previous example, they were all 3, but we could mix it up. So, for example, sometimes you don't actually need. Sometimes, if you guys have linear algebra yet? No, probably not. Okay, no linear algebra yet. Okay, but you've seen matrices because they have them in algebra 2. Do you remember matrices? Okay, some of you remember matrices. Okay, I'm gonna run with this. Okay, so sometimes you have what's called a mirror matrix, where if you cut it down the middle, like a triangle, the two halves are identical, right? Basically, adjacency matrices and a few other types are like that. That's a good case where you can save memory by not having a whole square, right? You don't have to have the full dimensions. So let's take an example. I have this function, stagger me timbers. I know it's terrible. And we're going to store distances between two locations inside of this two-dimensional integer array called distances. So this is a two-dimensional array, but rather than giving it like a square shape, we're going to give it a triangle shape. The way we're going to do that is, first of all, we're going to have 3 rows. I'll tell you right now, we're going to have 3 rows in just a minute. But the rows are going to have different sizes. So the first row is only going to have 1 element in it. The second row is going to have 2 elements in it. And the third row is going to have 3 elements in it. So when I said that triangle shape, this is what I'm getting at, right? So some matrix, some information you don't need like a square shape. Sometimes you need more of a triangle shape, or maybe you don't know what the shape is, and some lines are going to be longer than others. When that happens, you can use a staggered multi-dimensional array to gauge that shape, whatever it is that you need to store the information that you have. So it's pretty straightforward. There are 2 ways to instantiate this one as well. We can do it this way, which is at the top. We can also declare that we're going to have an array with 3 rows and not specify the size of the columns to start, and then we can individually assign those rows. So we can assign row 1 to be a new integer of a new array of 1 integer. We can assign row 2 to be a new row of 2 integers, and we can assign the third row to be a new row of 3 integers. And then we would have to set the values individually. So both of these ways would have the same impact. All right, any questions about staggered arrays?
How come line 14, there's no number in the other box?
That's a good question. The question is, how come in line 14 there's no number in the other box? And that's because if we put another number in this box, that would make it a square array. If we want to have different sizes for the second index, then we don't specify that at first. We have to build them individually. If we put a number here, then all of the rows would be the same size. Does that answer your question?
You mean columns?
Well, in the picture here, they're columns, but in memory, they're rows like this. I should have turned this picture on its side. That's what it comes down to. So this is just a memory visualization. This is actually what you can think, how you can think of the data.
Oh.
This is what we're building right here. This structure right here.
Oh, you're right. Okay, you're right.
Okay. All right. Anyone else? Yes. Go ahead.
With after you bring up the new way and you see the distances like 0 equals new, is that saying like the first row or first column?
Okay. So this is specifying the rows in this case, the rows of data. The rows of data as we would have them up here. So like row 0 would be this one right here.
I just didn't know because I see like you then go to like 0, 0, like the first position, second position.
Yeah. But does that clear it up for you?
A little bit.
Okay. Are you still confused? Is there something I can further clarify? Or do you think it's just something you need to like?
It's something you get used to.
Okay, yeah, and that's totally cool. If you just need to get used to the stuff, I totally understand. It's not all straightforward, and it takes some time
Kind
to
of
get it.
slanted.
It is. It's not the way that it's not your grandmother's data, right? Okay, so I'm just going to keep making bad jokes. You really need to get used to it if you're not used to it yet. Okay, so let's talk about those arguments that we see coming into the main method. Because we've always seen them, we've always had to add them when we're writing a Java program, but we might actually want to be able to use them. Probably the best way, the most common way to use them is from the command line. So let's say that we had some program that we were going to run, and in it, what we're going to do is we're going to expect somebody to type in 2 arguments after they type in the name of the program, and then we're going to print them out. Really simple program. We're going to args0 and args1. If we compile this with Java compiler, we compile that Java file, and then we run the Java program, and then we add 2 commands after it, fetch and ale. Then, when we do this print out, it's going to print fetch and ale, right? Because we grabbed the argument 0 and argument 1. Argument 0 is going to be fetch in this case. Argument 1 is going to be ale. And this is non-alcoholic ale, of course.
Butterbeer?
Butter, sure, it'll be butter. That's the butter ale. Butter ale. Okay. So, you guys haven't used this much yet. You did do some, if I remember correctly, you did do some command line stuff in this lab, right? Yeah. So, there are some useful aspects of doing the command line stuff. It's good to get used to. I did want to bring it up here and make sure that you understood how you can actually use input from the command line as well. Yes?
How did you print that inside of a parentheses or inside of like quotes?
So it's tricky, and maybe I should do some highlighting to make it more clear, but the quote starts here and ends here, and that's an open bracket.
Oh,
And then I have the variable, and then I have another bracket. This is another string here.
okay, gotcha.
And then another one at the
Ooh,
end.
yeah.
Okay? So, yeah, it's a little sneaky. Yes, hand waving in the back.
What if you have the square brackets right after the word string as opposed to right after arg?
So what if I have the square brackets right after the words? Honestly, I think actually that that's the standard way to do it, is actually to have the brackets right after the word string. The answer is in Java, they actually mean the same thing. But I think the brackets after the word string are actually the preferred version in Java now. So the other one works for backwards compatibility for older languages. Does that answer your question? Yeah. So actually, I'm just old habits die hard. I grew up doing C and C++, and this is the style in C and C++. It works in Java, so Java lets me get away with it. But people who wrote the Java language will tell you, no, don't do that. That's bad practice. So they would be mad at me for showing you that. Okay, anyone else? Okay, so this is pretty straightforward. I think we looked at object arguments before, so we can skip over this. We looked at the Batman example. And we looked at the array function. Okay, so we might actually be pretty close to the end of the lecture stuff. We are close, yes. Okay, so we're probably going to finish a little early today, and I'll take more questions because there were people lining up a lot last time. So when we talk about data structure, when we talk about storing information in containers, we've looked at arrays, like that's the most simple type of container. It's really important that you understand how to work with arrays because they are very, 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 very common. They exist in every language. They are a building block of more complex data structures. With that said, in Java and in most object-oriented programming languages, there are also a lot of other storage containers that are provided for you. One of the most common ones is lists, and lists are very similar to arrays in that they are sequential. They're one after another. The one that many of you have discovered, because it's very similar to arrays and it does a lot of work for you, which we're not letting you use, I'm sorry, is the array list. And the array list class is basically an array with extra stuff. It's an array with benefits. So it's an array, and it'll keep track of how many elements you have. It'll keep track of how many are full, how many are empty. If you run out of space, you don't have to worry about that because in the background it will double the size of the array for you without even telling you. So you can just add stuff to it. It'll let you rearrange stuff and pull stuff out really easily. Things that usually you would have to do manually, you would have to do on your own. Array lists will do all those things for you. And that's exactly why we're making you use actual arrays and not array lists for the project, because it's really important to learn how those things work, because they're not free operations. They actually are pretty expensive. But after this project, you are actually welcome to use array lists anytime you want. So that's an array list. There's also another data structure that you're going to get into more when you actually get into the data structures and algorithms class called a linked list. And linked lists, rather than having one section of memory that's all right next to each other, linked lists basically have pointers. They have references to the next element. Right? So you have the data and you have the next element. And you have the data and you have the next element. And you have the data and you have the next element. So linked lists are basically, they have these things we call nodes, and they have links. And they can hold data, but they don't all have to be in the same place in memory, so we can kind of jump around. That makes it really easy to add memory or to take memory away. To add stuff and to remove it from the list. With an array list, that gets a lot harder because resizing an array, you basically have to delete the old array and make a new one every time you do that. And that's what an array list does for you in the background. A linked list isn't like that. A linked list, you can just tack something onto the front or tack something onto the end, and it really doesn't cost you much of anything. The drawback is that arrays are really fast. And linked lists, because you got to jump through a bunch of links, they're a little bit slower. So these are two data structures that are pretty common that you'll see a lot more of, and they're linear in nature. One other type that a lot of you guys have discovered is what we call associative arrays, also known as maps. The most common one that a lot of people have discovered is called the hash map in Java. You may also hear maps referred to as dictionaries in some languages because they're like, they act like dictionaries, right? They associate some key with some value, some word with some definition in like a traditional dictionary. So we have a key which helps us find something we're looking for, and we have a value which is the thing that we're actually looking for. So here's an example. I might have a map, and this is pseudocode. This is not proper Java code. I might have a map, and I might decide that I want to add the key aardvark with the value raccoons with long noses. Maybe I also want to add beaver, and the value of the beaver key is rats that build dams. And maybe I want to add another key, zebra, that leads to striking horses. And then if I go to the map and I say, hey, find find the description of zebra, if I go to it and I say, give me the description of zebra, it's going to print out stripy horsey, right? Yes?
Why don't you guys do system.out.print?
Oh, because this is pseudocode, it's not proper code. This is not actually, you can't compile this, it won't work. This is it. I'm just giving you the general idea of a map. I didn't want to do the proper code because, especially in Java, it's very wordy using maps, and some of you guys have started using them know this. You can use them, but I didn't want to get into like really deep syntax. So this is pseudocode. That's why. Does that answer your question?
Yeah. Thank you.
Yes. Can you use this for the lab? For the lab, yes, absolutely. You can even use it as an auxiliary, as an extra, secondary, not primary, not holding the main data structure for the project. What you can't do is use it as the main data structure for the project. But yeah, please, use this anytime. Actually, associative arrays are fantastic. They're one of the most underutilized data types among early programmers, and they're super useful. They will save you so much time. I highly recommend using them. There's two different variants in Java, and in most languages there's two different variants, hash maps and tree maps. Hash maps have wonderful average case. That means in the average situation, they're super fast. The only problem with hash maps is that in the worst case scenario, they're really bad, which is very rare. It almost never happens. But if you have a case where you absolutely need a guarantee, tree maps have much better worst case scenarios. So that's something you can, weigh. If you're doing like life support program, you probably want to use tree maps, right? If you're doing almost anything else, hash maps are probably going to be better. Okay, does anybody have any questions about any of the stuff that I've covered up to this point? All right. So we will have a quiz on Tuesday, and if you have questions, come up. Take care and have a good week.
What's going to be on, like, what do we need to read?
What's that?
What section do we need to read for next class?
I actually put it up on the campus.
Okay.
It's, I think it's chapters 8 and 9. So